Previously, we've talked about proportions, and we're going to use proportions and cross multiplication to solve application problems. These types of problems align very closely to things that we encounter in real life all the time. We just may not recognize it as that. The grocery store, for example, they'll have sales that are some amount per given weight, and based on quantity, right, it will change the amount that you pay, or the amount that you pay, right, you can figure out how many of something you would actually have purchased. This is how you can actually figure that out. Okay, so the first thing to remember is what a proportion is. And I also want to point out that up here in the instructions, it says to use proportions to solve. So make sure that you look at the instructions, and if there's a way that is specified, you need to use that way. If you have another method that you have more experience with, I suggest using that to check your result, doing the way that you may be less comfortable with, because you want to know both, but you also need to take the time to learn the new thing, which admittedly can feel kind of frustrating sometimes, or certainly challenging, but we need to push through that so that we build our toolbox of math tools that we have. Okay, so for number 1, it says, if Clara can buy 5 packs of paper for $28.75, how much would 7 packs of paper cost? Now, I know, being a proportion, that the setup of this problem is going to look like this. Right? I have an equal sign with a ratio on each side. Now I need to go set everything up. When you have a proportion that you're using to solve, you're going to have one ratio that has a value in both the numerator and the denominator, and then one that has a missing value, and that's what you're solving for. I look at the units and place them first, and then I put the corresponding values next to them. So looking at this first sentence, it says that Clara buys 5 packs of paper and it costs $28.75. So there are 2 units in this. There's packs. You could say paper, just as long as you're consistent. And then money. I'm going to place those same units in the same position over here on the right. And money. Now I just put the numbers in place. By doing that, I don't have to be thinking about what goes where. The units need to be the same on both sides, and they need to be in the same position, which is what I have here. So the left-hand side goes with the 5 packs for $28.75. And then we've been given packs, right? How much is what we're solving for. So I put the 7 here, and then the unit of what I'm solving for, right, shows me where my variable needs to go. Now, to reduce any potential confusion, I'm going to remove the unit that's sitting next to the variable for now, but you have to remember that when you solve, the unit has to end up in your final answer. We've been told that we need to use solving with proportions. So in order to solve a proportion, we want to use our cross multiplication. So I am multiplying x and 5. So I get 5x equals, and then I'm multiplying the $28.75 times 7. Okay, so I'm going to clear my calculator here. And I have $28.75 times 7. That gives me 200. I'm going to put that unit in there because I don't want to forget it. Often I'll do that with dollar signs because dollar signs, well, look like dollar signs, but some variables can look like numbers, or there can be a bunch of different variables, right? And so I usually leave units, letter units out until the end. Now we've got x connected to a 5. That's the only thing on the left-hand side. So I need to cancel that multiplication by dividing by 5. So I get x equals, now this is one where the number that's already on the calculator is what's being divided into. So I can just do divided by 5, and that will give me my answer. Remember, it's dollars, and it's $40.25. So that means that 7 packs cost $40.25. Number 2 reads, last year at the fair with 25,250 attendees, 757 people bought funnel cakes. If 850 people bought funnel cakes, how many people attended the fair? All right, this is the same thing, right? If it doesn't say to use proportions, the way that you know you have proportions is that you have 2 different units that are related to each other somehow, and you have one missing value that you're looking for, and you're using that comparison in that proportion to find the missing value. Okay, so I did my one read through. Now I'm going to start underlining the important information. So first of all, I notice that I have people or attendees and cakes that are my units, right? So I also know this is a proportion problem. So I need to write my framework there. Now I have the total attendees, right, were 25,000. So actually I'm going to do attendees. 757 people bought funnel cakes when the attendance was the 25,250. So we have, just to not use confusion, I mean, attendees, right, and people are similar. I'm still going to go ahead and put people because that's what we're actually solving for. You can use any unit as you're working through the problem as long as you make sure it's the correct unit at the end, right? So if that felt confusing, you could go ahead and use like funnel cakes or something like that, whereas that's not actually the unit at the end. But again, attendees and people are somewhat similar, so I could see some potential confusion there if you're not careful. Okay, so I'm placing the units so they're in exactly the same position as on the left side. Now I start putting the information in. So I have 25,250 and 757 people bought funnel cakes. Now we have if 850 people bought funnel cakes, so 850. How many people attended the fair? So that is my unknown. I'll go ahead and call that X. I want to mention here that it doesn't matter the location of the units. So if I put people on top and attendees on the bottom, as long as it's on both sides, that will get you to the same answer. So don't worry about location as long as they're in the same position on both sides. Whether you use it, put a unit in the denominator versus the numerator doesn't matter as long as it's consistent. Now we're ready to do our cross multiplication. So I'm going to go ahead and show that. I have 850 times 25,250. That equals a large number. 2250. Okay, there we go. 21,462,500. And that equals my 757x. I have a term with a variable, and that's all on the right-hand side. So I'm ready to divide. So divide by 757. And we get a non-whole number. But in real life, right, if it doesn't make sense to have a partial answer, and here since we're dealing with people, it doesn't make sense to use a partial person. So when I write this answer, I just give the whole number version, right? So I need to round. And since there's a 0 to the right of the decimal, that means the last digit does not change. So 28,352. Now, if you're unsure of what unit goes with your final answer, you can look back at your proportion, and the unit sitting next to that variable is the unit that goes into your answer. I love that little trick because it can be easy to forget what the unit of your answer is. And here, especially since attendees and people mean the same thing, right? In this case, we're talking about an entire group, that's the attendees, versus the group of that larger group that did something, which in this case was bought funnel cakes, right? So having pre-labeled it and already being able to go back and see what unit is sitting next to the variable can be super helpful. All right, so looking at number 3, we have a group of overlanders had to escape a storm with falling trees. Due to the road conditions, it took them 45 minutes to drive 1.5 miles. At that rate, how long did it take them to drive 5 miles? 2 units. I have one complete ratio and one ratio that's missing something. And that tells me I need to set up a proportion. So there's my framework. Now I need to look and see what my units were. Notice this first sentence doesn't actually mean anything. There's no useful information. This also doesn't mean anything. Here, we have information about how long it took to drive a certain distance. So my units, I'm going to put minutes up in the numerator and then miles in the denominator. Because I did that, I need to do that on the other side. And then I'm ready to put my numbers in. All right, so 45 minutes, 1.5 miles. Okay, and then minutes is what I'm solving for. And so I put 5 there for miles. Now, cross multiply. I'm going to clear my calculator just so I don't confuse myself when I get over there. So I multiply, and then I multiply. So 5 times 45 is 225 equals 1.5x. Okay, just so I have more space here, I'm going to rewrite this. My x is by itself, right? Well, it's in its own term. There's something sitting next to it, so I'm ready to do division. Okay. I already have the 225 on my calculator, so I can go ahead and divide by 1.5. And that gives me 150. Now, the unit next to my variable is minutes, so I know that it's minutes. Now, here's something. This problem does not ask for it, but it could have given you the information the way that it did, right, in terms of number of minutes and a certain number of miles. But it could have asked, how many hours did it take? Well, in that case, you would need to convert your minutes to hours. Well, there are 60 minutes per hour. So that step would be the answer of minutes divided by 60. And that will give you the answer in hours. Okay, divided by 60. And that is 2.5 hours. I just wanted to mention that because sometimes you'll see that where the units in the problem do not align with the units you're being asked to find. And if that happens, that will always mean that you have a conversion that you need to do, meaning you go from one unit to the next. And there are conversion factors. And in a future video, we'll be doing more of this. Some of them that you already know are, 60 minutes in an hour, 60 seconds in a minute, 12 inches in a foot, right? Let's see, 3 feet in a yard. So there's some that you may already know, and you'll learn some more in future videos. But yeah, just something to pay close attention to, because it's easy to get caught with that because we're not used to having to pay attention to those units. All right, go ahead and pause the video and try number 4. Again, you need to use proportions. If you have another method, you could go ahead, I suggest as you're learning, to do the new way first and then use what you're more familiar with the second way to then check your answer. So number 4 says, Jay is hosting a party and planning to serve pasta. They have 25 people coming to the party. If 3 boxes of pasta feeds 4 people, how many boxes does Jay need to feed everyone? Round your answer to the nearest whole box of pasta. All right, so we have 25 people coming to the party. We have boxes and people. Okay, so I need to use my proportion, create my framework. I have boxes and people and boxes and people. All right, now I start putting the numbers in. So 3 boxes, 4 people. And then let's see, we have 25 people, right? And we're solving for boxes. I'm going to clear my calculator to start fresh. So now I multiply across and I get 25 times 3. That equals 75, there we go, equals 4x. Now I divide by 4. The 75 is already on the calculator, so I can just hit divide by 4. Okay, now this is one where you have a number of boxes that you need. Well, you can only purchase whole boxes off of shelves, right? You can't go to Safeway and buy a partial box of pasta. So in this case, if I didn't round that, right, that's not something that I could actually go out and purchase. So we need to go ahead and round this. So we take our 18 and 75 hundredths. So 18 and 75 hundredths, and that equals 19. And again, we can go back to our unit to double check. Boxes. Now, if, for example, I'm going to change colors because I want it to be clear that this is an if. It's not based on this actual problem. But if we calculated everything out and we ended up with an answer looking like this, and it's boxes, so we know we cannot have a partial box, so we need a whole number answer. Normally we would look at that and we would say, okay, well, the 3 is not 5 or greater, so my number would stay the same. Well, that would move me down to 18, which is not enough pasta to feed everybody. So these times that are related to real life, right, and you're talking about needing a quantity of something to feed a group of people, or I don't know, give people crayons, but the same amount of crayons, right? You have to think in terms of if it stays the same. So 18 in this case, does it feed everybody? The answer is no. So that means that this would also round to 19 boxes. That'll take a little bit of practice, but it's really important to be aware of. It was more straightforward here because the 1875 naturally, right, rounded up, but in this scenario, anything above the whole number 18 would round to 19.